Let x comma y be integer that satisfy the equation x squared plus 30x plus 25 equal to y to the power 4. Can we find the maximum value of x plus y? Of course yes, let's do it. So we are given the equation x squared minus 30x plus 25 equal to y to the power 4. Can I render this expression a perfect square? The answer is yes. We write x squared as x squared minus 30x is 2 into x into 15. Now that reminds us of the type a minus b whole thing square. So to make it perfect square, we simply add a square, so 15 square. But then the equality is not maintained. So what we do is we subtract 15 square plus 25 we copy as it is equal to y to the power 4 we copy as it is. Now you see that x square minus 2x plus 15 square, that's a perfect square. So we can write the given expression as x minus 15 whole thing square. 15 square is 225 and 25 minus 225 is minus 200 equal to y to the power 4. We copy as it is. Next, let's write this as a difference of a square equal to 200. So we take 200 to the right hand side. In the left hand side we got x minus 15 whole thing square minus y to the power 4. If we bring it to the left hand side we got y square whole thing square. Now we see it is a difference of 2 squares, so we can write it as sum and minus. We know that a minus b into a plus b equal to a square minus b square. A minus b into a plus b equal to a square minus b square. So a minus b, so x minus 15 minus y square into x minus 15 plus y square equal to 200. Now you see that right hand side is an integer, left hand side is x and y are integer, x minus 15 minus y square and x minus 15 plus y square both are integer. So we observe that integer into integer equal to 200. Not only that, if both those integers are odd, then we get product to be odd. So left hand side will be odd, whereas right hand side is even. So that's not possible. So it must happen that at least one of them is even and maybe other is odd, or is it that both are even? Suppose if possible one of them is even and other one is odd. Is that possible? Let us simply add these two equations. So y square and minus y square will get cancelled. X plus x is 2 number of x, minus 15 and minus 15 is minus 30 equal to even plus odd is odd. But you see that 2x minus 30 is odd is not possible. So it is not possible that one of them is even and other is odd. So this is not possible. So what is possible? Both are odd, not possible. One of them even, other odd, not possible. So the only possibility is both are even. So it follows that both x minus 15 minus y square and x minus 15 plus y square must be even integers. Let us divide equation 2 by 4. So dividing equation 2 by 4 we obtain, we divide this one by 2 and this one by 2 and 200 by 4. Now 200 by 4 is 50. This is, since x minus 15 minus y square is even, this is still an integer. This is also an integer. So we find that product of two integers equal to 50. Now if product of two integers equal to 50, those integers must be factors of 50. So x minus 15 minus y square must be factor of 50. What are the factors of 50? 1, 2, 5, 10, 25 and 50. Of course negative signs are also there. We'll do that separately. So when one of the factor is 1, since the product is equal to 50, other factor must be 50. When one of them is 2, product is 50, so 2 into 25 is 50, 5 into 10 is 50, 10 into 5 is 50, 25 into 2 is 50, 50 into 1 is 50. So those are the only possibility. So if one of them is 1, other has to be 50, one of them is 2, other has to be 25. What if one of them is minus 1, other has to be minus 50. So we write plus minus, but it's understood that both are of same sign. If this one is positive, this one is also positive. If this one is negative, this one is also negative. So these are the only possibility with the assumption that both of them are having same sign. Let's subtract this. Okay, let's call this to be equation. So far we have used 2. So let's call this to be equation 3. Let's call this to be equation 4. Let us subtract equation 3 from equation 4. We get simply y square on the left hand side. What about the right hand side? 50 minus 1 is 49. And minus 50 minus of minus 1, that's plus 1, that's plus minus 49. 25 minus 2, 23. So plus minus 23. 10 minus 5, 5. Plus minus 5. Plus minus 5. Plus minus 23. Plus minus 49. Now you see that y square has to be a perfect square, and y being an integer, y square, this is not a perfect square. This is not a perfect square, this is not a perfect square, this is not a perfect square. Since y square is a perfect square, only possibility is y square equal to 49. So y equal to plus minus 7, and that correspond to the case x minus 15 minus y square equal to 1 and x minus 15 plus y square by 2 equal to 50. Again by the case x minus 15 minus y square by 2 equal to minus 50 and x minus 15 plus y square by 2 equal to minus 1. Let's add those two equations. Y square will get cancelled and you get x minus 15 equal to 51 or x minus 15 equal to minus 51. In this case x equal to 51 plus 15, that's 66. In this case x equal to I happen to make a slight mistake. The question says plus 30 and I wrote it minus 30. So let's change it to plus 30 and x plus 15 plus hey, there isn't much change. That anyway, everything agrees nicely. So x plus 15 must be even integer. Wow, it agrees nicely, right? Even though I made mistake. And so we find that x plus 15 and yes. So y square is a perfect square. From there we find that x plus 15, okay. So adding we get x plus 15 equal to 51. So x equal to 31. And then x plus 15 equal to minus 51. So x equal to minus 66. Therefore, possible pair x comma y are given by x comma y equal to 31 comma 7 comma 31 comma minus 7 minus 66 comma 7 and minus 66 comma minus 7. But we want the maximum value of x comma y, x plus y. If we solve the equation x plus 15 equal to 51, then we get x equal to 36. So the possible pair x comma y is given by 36 comma 7, 36 comma minus 7, minus 66 comma 7, minus 66 comma minus 7. Therefore, maximum value of x plus y is given by 36 plus 7, that's equal to 43, and we are done.